Assalamualaikum and good morning to all of you. Okay, so this video is to discuss some examples in the last chapter, which is sequence and series. Okay, so we have discussed example here. Okay, the first example, sequence, we have discussed this one, and then next is this series. Okay, but in this example, it is called as the if I'm not mistaken, it is called a telescoping sum, but I'm not sure whether in the syllabus uh, it has special name or not, but as long as I know, it is called as telescoping sum. Okay, so find the kth partial sum. Okay, you need to find the partial sum of the series. So that's why you need to do the partial fraction and then expand the series. Okay, so how many terms that you need to expand, it depends. It is until you understand the pattern of the series. Okay, so selagi you cannot understand the pattern of the series, okay, so you can expand as much as you want. Okay, so today we will continue with the next one. Okay, so you are given this one. Okay, so at the first glance, okay, so boleh tengok yang ni, this is actually similar to if we are looking at the test. Okay, the appropriate series to be used is the ratio test. Okay, because we said that ratio test is for n's power. Okay, but before we use the test, okay, let's understand the question. Okay, determine the convergence of the series. If it is convergent, find its sum. Okay, so although it is n's power, okay, the case is n power, but it is not suggested to use the ratio test because we have 1 here, okay, which cannot be reduced or simplified during our solution. Okay, so let's simplify the series first. Okay, so this series we can separate the numerator and denominator. 5 to the power of n, 7n plus 1. Okay, 1 plus 5 to the power of n, we can separate the denominator and numerator. So let's simplify it some more. This 1 over 7 dot 7 to the power of n plus 1 over 7 5 over 7 to the power of n. Okay, so 1 over 7 here is the coefficient, so we can write the coefficient outside of the sum symbol. Okay, plus 1 over 7 5 over 7 to the power of n. Okay, so from here we can already conclude the convergence of the series because this is a geometric series. Okay, so let's compare with the geometric series. Okay, by the geometric series, let's see. Okay, so AR to the power of n, if R is less than 1, converge. If R is greater than 1, diverge. But if R equals to 1, no conclusion. Okay, R less than 1, converge. R greater than 1, diverge. Okay, so let's see for the first series. Okay, so the first is this one, 1 over 7 to the power of n. So this one, what is R? R is 1 over 7, which is less than 1. So this series converges. Okay, so what about 5 over 7 to the power of n? R is 5 over 7, which is also less than 1. Therefore, this series converges. Okay, so since both series converges, okay, so we can conclude that since both series converges, therefore the original series 1 over 5 to the power of n 7n plus 1 is also converges. Okay, so now kita ada dua series. Okay, so the first one, the summation for this series 1 7 to the power of n. So okay, the first series summation of 1 over 7 darab 7 to the power of n. So in this case A kita adalah 1 over 7 and R kita pun 1 over 7. Okay, so the sum of this series is A R divided by 1 minus R. Okay. Okay, so akan dapat 1/42. Okay, kemudian series kita yang kedua 1/7 darab satu lagi adalah 5/7 kuasa n. Okay, so dalam kes ni A kita adalah 1/7 dan R kita adalah 5/7. Okay, so summation of this series is 1 over 7, 5 over 7, 1 minus 5 over 7. Okay, so dapat 5/14. Okay, so summation for the whole series, summation of 1 plus 5 to the power of n divided by 7 to the power of n plus 1 adalah 1 over 42 plus 5 over 14. Okay, so dapat 8/21. Okay, so this is the sum of the series. Okay, so soalan dia tadi determine the convergence. So kita dah check, kemudian kalau dah converge then we can find the sum lah. Kalau dia diverge we cannot find the sum. Okay, so next question. Okay, determine whether this series converge or diverge using the limit comparison test. Okay, so first kita try to simplify. Eksponen n plus 1 kita boleh pecah dua, jadi eksponen n darab eksponen 1, kemudian eksponen n plus 1. Okay, so we can cancel this one. Okay, so dia ni adalah coefficient. Okay, so kita boleh compare, this is an, the given series is an, and then for the series yang we want to compare, kita boleh compare dengan eksponen 1 over n. So this is a harmonic series. Harmonic series, okay, dia harmonic series. Okay, harmonic series yang 1 over k tu kan, dia adalah diverge. Okay, so ini adalah harmonic series. Eksponen 1 ni hanyalah dia punya, kita boleh tulis dia macam ni lah, 1 over n. Okay, dia hanyalah coefficient sahaja. Okay, so we compare with exponent 1 darab 1 over n, which is a harmonic series and diverges. Okay, so by using the limit comparison test, so limit n approaches infinity, an over bn. Okay, an tadi adalah exponent 1 divide by n plus 1. Okay, divide by exponent 1 divide by n. Okay, so kita boleh rewrite balik this function darab n over exponent 1. Okay, again kita boleh cancel. Okay, so ini kita akan jadi n over n plus 1, which is akan dapat infinity over infinity. Okay, so kita boleh lah nak guna L'Hopital's rule boleh, ataupun boleh divide by n. Okay, sebab apa? Sebab awak akan dapat infinity over infinity indeterminate form. So kita divide by n, atas tu jadi n over n, bawah jadi n over n plus 1 over n. So limit n approaches infinity, 1 over 1 plus 1 over n. So when n approaches infinity, this part akan jadi 0. So dia jadi 1 sahaja. Okay. Okay. Okay, so we said that this is row. Okay, dia ada nama special which is row. Okay, and then in this case our row is equals to 1, which is syarat row kita dia mesti between 0 to infinity. So 1 ni between 0 and infinity lah. Therefore an dia akan ikut bn, which is diverges. Okay, kenapa dia diverge? Sebab dia ikut
by the limit comparison test, dia akan ikut BN. Okay. So soalan seterusnya, okay, we need to use the divergent test. So what is divergent test? Okay, divergent test kita kena guna limit lah. So in this case kita akan cari limit k approaches infinity, natural log 2 over k. Okay, ni simple je, 3 markah saja. So again, macam mana behavior of natural log punya function? Okay, ini adalah natural log. Okay, so bila k ni approaches infinity, ini dia akan approaches 0 lah. Okay, this part. Okay, dalam this function, okay, when k approaches infinity, 2 over k ni dia akan approaches 0. So, apa berlaku pada natural log bila the function approaches 0? Okay, ni approaches 0 lah ni. Okay, this is 0 kan? So, when this function approaches 0, so dia akan approaches negative infinity. Okay, so by the divergent test, okay, if the limit of the series, the limit of an does not equals to 1, so kita kata an diverges lah. Okay, therefore we conclude that natural log 2 over k diverges. Sebab kita dapat negative infinity, which is does not equals to 1 ke does not equal to 0. Let's check. The divergent test. Okay, sorry, does not equal to 0, bukan does not equals to 1. Okay, does not equal to 0. So sini syarat dia does not equal to 0. Okay, so kita kata dia diverges. Okay.
Okay, jadi soalan seterusnya integral test. So soalan ni dia dah highlight using integral test. Okay, tapi soalan ni, okay, dia dah bagi idea ke awak lah. Okay, this is the original series. Okay, dan dia dah bagi idea yang awak mesti menggunakan partial fraction. Okay, in order to use the integral test. Okay, sebab kalau kau tak guna partial fraction, okay, nak guna u substitution pun tak sesuai lah. Sebab ini kalau ambil u sama dengan, kalau awak let u, okay, let's say kita directly guna integral test kan. So fx adalah 5x tambah 4 per x kuasa 2 tambah x kan. So kalau kita buat u kita adalah x kuasa 2 tambah x, then du sama dengan 2x tambah 1. So dia jadi tak boleh cancel lah dengan 5x tambah 4 ni. Okay, jadi dia tak boleh directly guna integral test, so awak kena go through the partial fraction. Okay, so dia dah bagi idea partial fraction. Okay, so boleh factorize denominator dia jadi n dengan n plus 1. So kita just perlu cari a and b lah. Okay, so 5n tambah 4 per n darab n plus 1 sama dengan a per n tambah b per n plus 1. Okay, so yang ini pun dia agak mudah dia punya partial fraction. Okay, so awak boleh compare 5n tambah 4 sama dengan a darab n plus 1 tambah b darab dengan n. Okay, so kita boleh gantikan n kosong. So kiri jadi 4 sama dengan a, b kosong lah. Kemudian boleh gantikan n negatif 1. So ini jadi negatif 1 sama dengan negatif b. So b sama dengan 1. So partial fraction kita ni dia jadi 4 per n tambah 1 per n plus 1. Okay, so itu yang pertama lah, simple je. So markah dia pun tak banyak, 7 je total. And then determine the convergence of this series using integral test. Okay, so kita sebab kita dah buat partial fraction, so kita boleh asingkan dia. Fx, define dulu fx 4 per x plus 1 over x plus 1. Okay, so kalau nak guna integral test, limit t approaches infinity from 1 to t 1 to t from 1 to t 4 over x plus 1 over x plus 1 dx. So limit t approaches infinity, dapat 4 natural log x plus natural log x plus 1 from 1 to t. Okay, so limit t approaches infinity. Okay, kalau kita substitute t, natural log t tambah natural log t plus 1, tolak 4 natural log 1, tolak natural log 2. Okay, so natural log 1 ni dapat kosong. Okay, so macam mana natural log punya graph macam ni. So when t approaches infinity, ini akan jadi negative infinity, ini akan jadi when t approaches infinity. So when t approaches infinity, so ini akan jadi infinity, infinity. Ini nombor biasalah sebab natural log 2 kat sini. Ini 2. Ini adalah natural log 2. Okay. Jadi, tapi disebabkan kita tambah dengan infinity, so overall kita akan dapat infinity. So bila di infinity, kita kata limit dia adalah diverges. So this series diverges. Okay, by integral test, this series diverges. 5n plus 4 per n plus 1 diverges.